Welcome. So in this lesson, we're going to begin talking about probability tables. Let's read this definition before us. A probability table is an alternative to a Venn diagram when illustrating a probability problem diagrammatically. Consider the Venn diagram which illustrates two intersecting sets A and B. So here it is right here. From the Venn diagram, it can be seen that the sample space is divided by the sets into four disjoint regions. This one, this one, this one, and this one. These regions may be represented in a table as follows. Such a table is sometimes referred to as a Karnaugh map. So here is the table before us. And this table is sometimes referred to as a Karnaugh map. Sometimes it's just referred to as a probability table. But here it is. So what we're going to do now is spend a few moments just appreciating how the Karnaugh map is related to the Venn diagram. So as you can see here, we have A and not A, and B and not B. If we want to find where A and B intersect, it's just going to be this region here. And that corresponds to this part of the Venn diagram. And then we can apply that logic to other parts. So for instance, not A and B correspond to this. So the intersection of not A and B is here. And if I was to come to my Venn diagram, that would be this section right here. So not A intersecting of B right there. We could continue. What about if we wanted to find not A and not B? So the probability of the intersection of the complement of A and the complement of B is here, and that would correspond to this part. So that's how we read off the Karnaugh map and see how it relates to that. Now, before we move on, there's one last thing I want to show you, and that is, let me grab this. As you can see, A, so the probability of A is made up of these two parts. So the probability of A intersection of B and the probability of A intersection of not B. So when you add these two parts together, you get the total probability of A. And the same thing can be said for the probability of B. When you add up this and this, you get the total probability of B. So when you add up these two parts, you get the total probability of B. And again, we can represent this on our Venn diagram here. So that is everything you'd have to add up to get the total of B. And then this is everything you'd have to add up to get the total of A. And what we also know is if we go the probability of B plus the probability of the complement of B, so the probability of B occurring and the probability of B not occurring, that has to be equal to 1. And say the same thing would be true for A. So the probability of A occurring plus the probability of A not occurring has to be equal to 1. Okay, so that's where we'll leave this little introduction here. We're going to dive into some examples now and make some more sense out of Karnaugh maps.